you have to show that one is a subset of the other and the other is a subset of the one, the first one. Okay? And how do you do that? Well, you show that every member of this is a member of that, and if that's the case, this is a subset of that, and you have to show every member of this is a member of that. In other words, this is a subset of that. Okay? So to prove this, we will let's say x, little x, be a member of this, and show that that member x belongs to this. And we'll let x be a member of this set, and we will show that that x belongs to that. Okay? And therefore, this is a subset of that. Okay? So that's our proof technique. We're showing that two sets are equal. So we do it in these two parts, using the arguments of subsets. One is a subset of the other, and the other is a subset of the one. Right? That's what we're doing here. Okay. All right. So which way we'll go? We'll go say from left to right. So we'll take an arbitrary member of this set. Let's just call it x, little x. So we'll let little x be a member of this set, and we'll try to prove that that x also belongs to this set. Okay, for any x, for any member of this set. And if that's true, then this set here is a subset of that one. Right? And then for the second half, we'll go the other way. We'll let x be a member of that. Any member. X is an arbitrary member of this set. And if it's a member of that set, we will then show that x is also a member of this set. And if that's true, therefore this is a subset of that. Okay? Alright, now we get into the nitty-gritty, the real detail. Right? And this is our first actual proof for the whole course of many hundreds? I'm not sure. Certainly many dozens of proofs. Maybe 100 or two, I don't know. I haven't counted, but yeah, quite a substantial number of proofs in the whole text. I mean, it's 420 pages, right? Okay, so let x be a member of the set, this set here on the left, this left set. Okay, so x belongs to, now you familiar with the notation? What does this mean? The U here, that's the union. So when you combine two sets, A and B, so A union B is the set you get when you add the members of A and B together into one big set. You get A union B, and then the bar over it, that's the complement. That means so this would be it's the members that do not belong to the union of A and B. So it's members that are not in A or B. Right? That's what this set is. Okay. So if x belongs to this, then you know that x cannot belong to A union B, right? Which is sort of the opposite. So if x belongs to that set, then x does not belong to what's under the bar. Right? So you know that x does not belong to A or B. Well, what doesn't belong to the union. Now, and you deduce this from the definition of what a complement is, right? Okay, now if x does not belong to A union of B, then x doesn't belong to A and x doesn't belong to B, right? That's from the definition of the union of two sets, right? So x does not belong to A and x does not belong to B. Well, that means that x does belong to A bar and x does belong to B bar, right? So x belongs to A bar and x belongs to B bar. Well, that means, in turn, that x belongs to the what's the word? Damn, the looks like an upside down U. What do you call that? The intersection. So X belongs to the intersection, this, of A bar and B bar, right? Oh yeah, here. So that's, that comes from the definition of the intersection of two sets. Right? X belongs to A bar and X belongs to B bar, therefore X belongs to A bar intersection B bar. Right? So we know that. So now, okay, we can pull things together a little bit now. So if X belongs to A union B bar, in other words here, we prove that X belongs to A bar intersection B bar. Right? So if X belongs to that, therefore X belongs to that. And that's the definition of a subset. Therefore, this is a subset of this. Right? Definition of subset. Here. So therefore, this here, this is a subset of this. Right? Here. Because if X belongs to that, therefore X belongs to this. Therefore, this is a subset of this. Follow that? Right? So this left-hand side is a subset of the right-hand. This left-hand set is a subset of the right-hand set here. Okay? Then I put a rectangle around it and label it 1. So that result 1. I'll come back to it. We'll need that. Right? So we'll need to find a result 2, and then we'll combine them. Okay, now let's go the other way. Now, the other direction. So now let X be a member of this set. Okay, any member, an arbitrary member. So X belongs to this right-hand side set. Right? So X belongs to that. Now it's the intersection. Now if X belongs to the intersection, that means X must belong to this and it belongs to that. Right? That's the definition of intersection. So X belongs to A bar and X belongs to B bar. Right? Now if X belongs to A bar, X does not belong to A. By definition, that's what the complement, the bar complement means. Right? So X does not belong to A. And similarly here, X does not belong to B. Right? So that means that X does not belong to the union of A and B. Because X doesn't belong to A and X doesn't belong to B, so X cannot belong to the union of A and B. Right? So X does not belong to A union B. So therefore X does belong to A union B bar. Right? Right? So X belongs to that. Alright. Hope you followed that. If not, rewind. Right? And keep rewinding it until you think you get it. It's all there. Maybe I just went a bit fast. But it doesn't matter, right? Because this is a video lecture. The speed of the professor doesn't matter. So long as the content is all there, so long as it's complete. Because if it's too fast and you don't get it, it doesn't matter. You just rewind and look at the content again and again and again, as many times as you need. One of the great superiorities of a video lecture compared to a classroom lecture, as I was saying a bit earlier. All right. Okay. So we started. If X belongs to this set, that's the right-hand side. Okay. Then X belongs to this set, the left-hand side. Right. So if it belongs to the right-hand set, it belongs to the left-hand set. And therefore, the right-hand set, hold on, if it belongs to that, it belongs to this. Therefore, this is a subset of that. Right? This is a subset of that. And that's result 2. Okay? So we've got these two results. So, this is a subset of that, and this is a subset of that. Now look, this one's on the left-hand side here, and it's on the right-hand side here, but the subset sign is this way. So the only way these two statements can be both true, in other words compatible, is is if the two sides here are actually equal, right? And that's the whole strategy of this type of proof for proving that two sets are equal. Okay? You get these two subset type results, you combine them, and the only way that can be done is if the two sets are actually equal. Okay? So we've actually proved that they are equal. Here's the equal sign. That's the end of our proof, so we put the end of proof marker here. Okay? Now, it's the end of the session, but what we'll now do, we'll go back to, we actually give the formal proof now. The problem that was in example 019, that was the case of a graph, and you had to prove that the sum of all the degrees of the nodes was an even number. Okay, so we'll start off with proving that, the actual formal proof, in the next session. So what we're doing now is we're starting to see examples of full proofs, actual real-world proofs, and you will see many dozens, maybe well, let me. I don't know. My guess is maybe 100 or so actual proofs. Now, some of the proofs get quite long and difficult, right? Like pages per proof. So you can't have too many. There's 400. My guess would be somewhere between 100 and 200 proofs. Right? Maybe it is under 100, but if so, it's up there. Okay. So next. And you would probably see the first line, but so the next thing we'll do is theorem 0.21, and that'll be the formal proof of that problem about the number, proving that the number of the sum of the degrees of all the nodes in a graph, that number is even. We'll actually prove that that's the case. Right? And then in next session we'll get into a whole new section, 0.4, and we'll start talking about types of proof, various proof strategies, proof methods, if you like. And we'll talk 3 of them. By the time we finish that, a few sessions, we will have finished the chapter. We will have finished the introductory chapter, chapter 0, and then I have to bite the bullet, meaning I have to make a decision. Do I continue on to the theory of the next chapter and have a problem-solving session later, as I've done with quantum mechanics? I mean, I have a backlog now of about half the chapters in my second course on quantum mechanics. The problems I have not yet solved, and I'm beginning to think that's probably not a good idea. So I probably will have a problem-solving session after each theory chapter. The lectures on the theory of each chapter. Once that's finished, I'll then have a problem-solving session. I think it's probably better. Okay, so I'll stop there and then continue straight on.